Alright, so write the equation. I take it back, we do have a decent amount to do today. So, write two different equations using cosecant and secant. So we can do this two different ways. I'm going to do this relatively quick. So what I'm going to do is I'm going to graph in. Oop. Do you guys see what I'm doing right here?
Yes.
That's actually pretty good for me. I'm graphing in my curve that was made with this. These are my zeros. This is my amplitude. ER? Okay. So what do you guys want to do first, the secant or cosecant? I would do secant first, because what's secant? Secant is cosine. Now for this one, is cosine going to be negative or positive? Could I use a positive and shift it? Yeah. But wouldn't it be easier if I looked at this like it's going to be negative? What's my amplitude? 1. So it'd be negative cosine. I'm looking at the dotted line graph. What's my period of it? My period's 2 pi, so nothing's going to change in there, right? I'm not shifting. That's it, right? So now, but that's for the dotted graph, so what's my secant graph? It's the exact same thing, I'm just changing my cosines into secants. Because I didn't care about the dotted lines, I wanted the U's. So that's one, bless you, that's one answer. What's the other answer? Can I write this in terms of cosecant? If this is sine, I could look at either of these as my starting point, right?
Yeah.
Which one do you guys want to do? I like being positive too. So if that's my starting point, what did I do? Write pi over 2, right? So it'd be sine, my amplitude is 1. I'm positive because I went up. So it'd be x. If I go right pi over 2, it's minus pi over 2. Yep. Now sine, though, that's my dotted line, is actually cosecant. So what makes these tricky sometimes is, well, like sine and cosine, you could write any equation in terms of secant or cosecant. Just like you can write any curve as sine or cosine. That's why it's called sine and cosine, not sine in a different name because they're the same function. Co means together. All right. Ooh, write this using tangent and cotangent. All right, let's do cotangent first. Is this going to be positive or negative cotangent? Positive, because cotangent goes down. Where's cotangent usually start? 0, 0. But what did I do with my asymptote? We can go right or left. I actually went left on this one. So I'm going to go left pi over 4, right? Am I shifting it up or down? No. If I go over that, I go up 1, right? So nothing in front. So I'm going to do cotan of x plus pi over 4. Because I went left pi over 4. Could I have done x plus 3 pi over 4 or minus 3 pi over 4? Yeah, both work. Because I went right 3 pi over 4. Now for tangent, what am I going to have to do in front? Put a negative. Now for tangent, I start at a 0, right? What did I do with that 0? I went right pi over 4. So I'm going to do x minus pi over 4. And remember, because I told you these are the same, just moved over pi over 2, right? Negative pi. We kind of discussed that. So again, there's going to be a lot of different answers to these. All right. So we don't have an example to do, but I do have a page to do. Yep, I'm going to do... It doesn't even say example on it, but we'll do them. It does say... Oh, yeah, why didn't I say I was going to do example 9? It says do all 311. My bad, y'all. All right. So I'm going to show you guys using the key points method, and I'm going to show you guys using the other method. Again, I'm not a big key points guy, but that's fine. All right. So let's graph it. This is my equation. So if you guys remember this, I need to find my A, B, and C. What's my A? Yep, my amplitude, which is 2. What's my B? My number in front of X, which is 1 on this one, right? So my period's not going to change. What's my C? Am I going to write this negative or positive? It's negative pi over 2. Yeah, we'll put, but that means I'm going to go right pi over 2. Do I have a D? Only on my report card. Because it's in my name. All right. So if you recall, what's going to be my first point I'm going to graph? So cosecant goes with sine, right? And sine usually starts at 0, 0. Now, instead of starting at 0, 0, since I'm not shifting up, where do I go? I use my C to start. So what's my starting point? Pi over 2. So pi over 2 is my 0. Right? Now I'm going to find my period. What's my period on this? One's 2 pi. And again, this is what we do naturally, but we're just putting in words again in case you don't see it. So I'm going to go over 2 pi and put another 0, right? So that would be at 5 pi over 2, right? And then I'll put in my other 0 too. I'll go one to the left because it's on there. So I'm going to go to 3 pi, negative 3 pi over 2, right? Oh, that's what they're saying here. Keep doing it. Keep adding and subtracting your period until you get them all in, right? And that's what I just did. Now we make our 4 subintervals, which, what did I say? We cut in half and then cut in half again. So we've been doing this. So I cut this in half. Now for sine, what's in the middle? Another intersection. So I cut this in half. So 1, 2, 3, 4. I put a dot. 1, 2, 3, 4. Dot. 1, 2, 3, 4. Dot. Check, 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 check. Oh wait, I need to make my other intervals too. So remember, for sine, this is where I'm starting, right? Do I go up first or down first? Up. My amplitude is 2. So I'm going to go up 2 and put a dot in the middle. Then I'm going to go down 2, put a dot. Is this all ringing a bell? We've done this before. Look how beautiful this is. It's pretty as a postcard. All right, now let's draw it. Oh, no, no. Why has it got to be a dash line? It's construction line. All right, does it tell you what to do? Oh, once you graph that in terms of sine, what do? That's everything you need, right? We put in our asymptotes, which can be a pain in the... Never mind. And then what do? Put those U's in there. Put those U's in there. How many people do you think I could get their head to nod if I stood here, like, made eye contact? It's like, yep. Mm-hmm. 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 All right. All right. Now this one's called the transformation method. There's not really a difference, I'll be honest, but depending on your book. Let's graph another one. I don't know, we just gotta complete our notes. Alright. So my transformation method is I look for a vertical stretch, a horizontal stretch, horizontal or phase shift, vertical shift, right? So, this is key though. Remember, can I get all my information from that? What do I have to do to it? You have to factor out that 2. Okay, B has to be in front of the entire thing. You only get 2. Nope, no more. You only get 2. You can't be greedy with those. What? No, really? Oh, I hope that's not on video. All right. All right, what's my vertical shift on this one? -1, right? What do I like to do with my vertical shifts is I'm going to put in my construction line right there, because I'm going to treat that like my 0, right? I'm going to treat it like 0. C is my phase shift. This is done the exact same way we did. What are we going to be graphing here? Sine or cosine? Cosine, because secant goes with. It makes all the sense. Oh, Mighty Ducks 2. That was the Riz that they used. All right, with the Iceland chick. Watch Mighty Ducks 2. Coach Bombay was rizzing up the Iceland chick, and he got caught on an ice cream date with her by the team, and they got really mad. And that's what they were talking about on that film. That's a great film. Watch it. We should watch it after the AV test. There's the knuckle pucks in it. It's a good movie. Oh no. They'll be like, you can't talk about the flow of a movie. That's strike 2. Alright. Yeah, ask him. Oh yeah. Ask him if they can knuckle puck. Alright. So what are we doing? Negative cosine. Negative cosine, I start down here, right? Where do I actually start it because of my phase shift? I'm going to go right, pi over 2. Now, my amplitude is 2, so I'm going to count 1, 2, and put a dot, right? I did. You guys. Boop. Amplitude's 1. I got distracted. So we found C. C was pi over. We went right pi over 2. What's my horizontal transformation? None, because there's no A. But I went down 1. I don't like this. Whatever. This is all right. Let's just do how we did before. What's my period? Why is it pi? Yeah. So I add pi, add pi, right? Now if it's negative, what happens in between these? I go to my max, right? And then what happens in the middle of those? Zeros, right? But now, are these zeros actual zeros on this one? Now watch this, to be careful. Dot 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 dot, drawing dash lines because it's real fun. That's not right. That last one's not right. It's supposed to be here because it's clear that it's here. All right. Now for this one, what makes this a goofy gusset? Are my zeros actual zeros? No. But when I plug them in, I still get an asymptote. So I'm not graphing where these points cross this line. I'm graphing where they cross my new midline I made. So my asymptotes happen at not where it crosses this, but where it would have crossed if there wasn't a vertical transformation. Okay, so that's a new thing that we haven't seen yet. Does that kind of make sense? So you're always putting your asymptotes on your midline. No, because your zeros are these.
Yeah.
But what I'm saying is they're fake zeros.
Yeah. Zeros that I would think are.
It's the zeros you think are zeros, but they're not zeros.
But it's the right.
Well, fake the fake. Another great film. All right. Then I go through and I go, whoop, whoop. Wow, look at this, guys. Isn't this fun? I'm like the Bob Ross of trig graphs. Happy little curvy derbies. All right, whatever. That's the end of the video. Hope you all enjoyed it. Whoever watched it, all three of you out there in the world.